So today we're going to go ahead and talk about graphing sine and cosine curves. Now notice the key word there, they say curve. So obviously you know it's going to have something with a curve in it. It's not going to be probably something with a straight line. And so we need to go ahead and graph y equals sine x. And so in order to do this, we're going to focus on the key points. And the key points occur at 90, 180, 270, and 360. Now, this isn't going to be one where you're going to be able to rely on your graphing calculator to do these, because when we start getting into some shifts and things like that, you're going to have to be doing those by hand. Okay, so the key points, remember I said were 90, 180, 270, and 360. But if you remember, I said what we're going to do with those degrees is we're going to kind of throw them out the window and we're going to use things in terms of radians. So I'm really talking about 90, 180, 270, and 360. Okay, now those are our key points. Now, when I look at my chart, specifically like sine of 0, what is the sine of 0? It is 0. That's correct. So I know that my graph is going to have a dot at 0, 0. Now, I need to know what the sine at 90 is, or what the sine at pi over 2 is. Now, that actually might be in some of your homework problems, too. But the sine at 90, or the sine of pi over 2, what is that value? Might be even in some of your previous notes. There's sine of 180. There's a lot of them. 1 is correct. Okay? What is the sine at 180? Sine at 180, now that one I know is in your notes because I just saw it on yours. Zero. What's the sine at 270 or 3 pi over 2? What?
1.
Negative what? Negative 1. What's the sine at 360? Or the sine at 2 pi? It's 0 because it's just the same as it was at 0. Now you're going to notice the sign here occupies it's kind of like cyclic cycle. So you start at the middle, then you go up, then you go to the middle, then you go down, then you go to the middle. So then the next one is you'll go up, middle, down, middle. So that's kind of what we do. So this next one here, we would be at our up. This next one here, we would be at our down here. Okay, and so this is actually a curve, believe it or not. This is what a sine curve looks like. And so what we're going to do is we're going to go ahead and connect the dots. Now notice, it's not, oops, let's try that one again. It's not a V, so it's not a peak. It's just going to be a nice curve. Oops, crud. And I'm going to have to do the whole thing over again. I'm just going to do this. Okay, and so that's what a sine curve looks like. Now, sine curves are used a lot, especially in sound waves, especially in frequency. Like the tuning fork, if you were to hit a tuning fork, its waves are emitted in a sine wave curve. The other thing is, believe it or not, fluorescent lights in the classroom. How the light is distributed, maybe distributed isn't the word, but how the light actually comes out of the fluorescent lights is actually in a sine curve. It's not a constant light that comes out from the fluorescent lights. It's actually one that does oscillate. Looks a lot like a sine curve. And if we had they have a thing called a CBL, which is a calculator-based lab. It's got a light probe. If we were to put our probe up there it'll actually input the amount of light that's coming out from those and plug into our calculator, and it will do that as well. It will show that it's in a sine curve form. Okay? So that's what sine looks like. That's one of those things you need to file away. Sine always starts at the middle, and then it goes up. Okay? So let's talk a little bit about that sine function that we just got done graphing. So we're going to utilize our knowledge of all these different things that we've talked about early on. What is the domain? Yeah, the domain is left to right, but in this specific graph, what would it be?
0 to infinity.
What would it be?
Negative infinity.
Negative infinity to positive infinity, because if you notice, I put arrows on each of those, which means it doesn't stop. It will go all the way to the left and all the way to the right. No. If you notice, I put an arrow here, which means it'll go all the way to the left. Okay. All right, what about the range? -1 to +1. And we actually call this function an oscillating function, because the word oscillate means to go back and forth. It's kind of like a pendulum. Continuity, what can you tell me about the graph? It's continuous for all, continuous for the entire domain, or continuous for all x. So it's continuous everywhere. Or you could put negative infinity to positive infinity. Symmetry, what can you tell me about symmetry? Okay, let's go back and look.
No, it's line.
Oh, I guess it's not. No.
What does it have, Kate?
Origin.
Origin symmetry, because origin, remembers, you reflect along the y and then reflect along the x. So this one actually does have origin symmetry. And we already talked about the oscillation. What two values does it oscillate between? -1 to +1. Now, so that's something to keep in mind when you're doing that blue chart. You will never get a value bigger than 1 or less than -1 for sine. So now we're going to do the same thing with cosine. Okay? We have y equals cosine of x. Now cosine is kind of sine's partner. It's not totally the same. Okay, but it's similar. So we need to figure out, where does cosine start? So where does it start? What is the cosine of 0? Nope. Cosine of 0 is 1. So what do you think is going to happen here at pi over 2? What's the cosine of 90 or the cosine of pi over 2 going to be? Just for kicks, take a guess. Cosine of 180, what do you think, or cosine of pi? -1. So you can kind of see how this is going to oscillate now. What will be the next one? Oops, that one isn't quite on there. What will it be at 3 pi over 2? 0. Where will it be at 2 pi? 1. So you can kind of see how this one's going to work. So what can you tell me about cosine? Where does it start? Cosine starts at the high point, 1. Other than that, it just fits sine. Okay, so now we need to go ahead and connect the dots here. Now remember what I said, these are curves, so I don't want to see these. Okay, there does need to be a curve, because remember, absolute value is actually a v function. So now what we're going to do is we're going to go ahead and go through those different characteristics that we went through with sine. We're going to start with the domain. What's the domain here, folks? -infinity to positive infinity. So the domain is the same. What about the range? -1 to +1. So once again, that does stay the same. What can you do about continuity? It's continuous for all x. It's continuous everywhere, negative infinity to positive infinity. Now, there will be some trig functions that will not be continuous everywhere. We're going to have some of those asymptotes in there. What about the symmetry? Yeah, okay, yeah. What about symmetry now? What type of symmetry is going to happen here? Y-axis symmetry, because this side's going to now start to go down. Okay, so this one actually does have a y-axis symmetry. What can you tell me about the oscillation? -1 to +1. So once again, on that blue sheet, you shouldn't get anything bigger than 1 or anything less than -1, and that's really important to file away. Sine and cosine are never bigger than 1 and never less than -1. Okay, questions? All right, so what we're going to do is we're going to talk about some things known as periods and amplitude. Okay. Now it says a period, one period or one cycle of the sine and cosine function. Now when it says cycle, that means an area that does not repeat at all. Okay, that's kind of like the main part. You know kind of how you take a pattern sometimes and then you trace it over and over again? Okay, that's kind of what a sine and cosine curve is. It's a pattern, and I want to know that base pattern. What am I going to repeat over and over again? How long is that base pattern? So let's go back and look at the graph. Let's go back one more. Okay, if I was going to take this pattern and I was going to shift it over and repeat it and repeat it and repeat it, okay, how long would the original pattern, first pattern, have to be? 2 pi, good. Okay, and that's exactly right, because if you look at it, if I start here at 0, where's the next point that I start repeating again? At 2 pi, because that's the point. Maybe some people will say pi, but I don't repeat at pi, okay, because I go down. Okay, the next time I actually start at the middle and go up is at 2 pi. So one period, so let's go back to that slide. One cycle of the sine and cosine function is 2 pi. And it does hold true for the cosine curve as well. So things you're looking for is like middle to middle or peak to peak. That's like your high point to high point. A sinusoid is what we're going to be looking at then in this section. That is any transformation of a sine function. So that means, do we shrink it? Do we make it wider? Do we shift it over? Okay. But that's what a sinusoid is. And so then we have the amplitude. Notice there the amplitude. It's always the absolute value of A. The absolute value of A, which means the amplitude can never be negative. It's always got to be positive since it's absolute value. Half the distance between the maximum and the minimum values. So let's think about our graph of sine. The maximum value was what? 1. Minimum value was -1. What's the distance between 1 and -1? 2. Half the value of 2 is 1. So the amplitude would be 1. And so that's why when we graphed it, we just graphed sine of x, because there's actually a 1 there. So that amplitude is basically from the middle to the top or the middle to the bottom. So now what we're going to do is we're going to go ahead and look at some of the different amplitudes that a graph can have. And there's actually an infinite number it can have. But we're going to compare the two, and we're going to look at a few of these, and then we'll be done for today. Okay, we're actually going through, I think, 8 slides total, and we're on slide 5 today. Okay. So it says, describe how the graphs of y equals sine x and y equals 3 sine x are related. Now, I don't know if you necessarily need to write all that out. This is just the instructions that are in your homework. So basically, what we need to do is we need to figure out what's different between the two. Multiply by 3. So what, do we remember what this number refers to? The amplitude. That's what we just got done talking about. And so what's the amplitude of this graph right here? The amplitude here is 3. What's the amplitude of this graph? 1. So essentially what's going to happen is, if I were going to graph y equals sine x, okay? If I were just going to graph that real quick, ooh, that's a bad one, there we go. If I were just going to graph y equals sine x, it would look like this, right? That's what y equals sine x would look like. So that's just what we got done doing. Oops, there we go. Well, anyway, you get the gist of it. It's not perfect through those lines, but it's close. Okay, now y equals 3 sine x, instead of going up to 1, it's going to go up to what? 3, so it's going to do this. And at 0, it's still going to stay at 0. So this is what, okay, yeah, close enough. You can kind of see that. So what does the amplitude do? It makes it bigger. Okay, at least in this case it does. So that's what that y equals 3 sine x. So how are they related? It's the same graph except for one it just goes up to 3 as opposed to up to 1. So you could just say it goes up to 3 and down to negative 3. The other one goes up to 1 and down to negative 1. That's how they would be related. Something to that effect. You could do that. You could. It doesn't matter. It depends. If it says to graph both, yes, then you have to. If it just says describe how they're related, you could understand the idea with amplitude and not even have to draw it. I just did that so you kind of have a visual. Let's look at this one. Describe how the graphs of y equals cosine x and y equal 1/3 cosine x are related. Right. So basically, it's going to be real similar to the one we just got done looking at because it's going to be a multiple of 3. Okay, but my amplitude here is 1/3. Amplitude here is 1. So one is just going to be 1/3 the height of the other. Okay. So you could actually put that in words. Do I need to draw a graph or do you think you understand that? Okay. So it would just go up to 1/3. Now the key about cosine, remember cosine starts at the high point. So at 0, you would start at 1 and 1/3. Okay. All right, so if you want to go ahead and get this down, and this is where we'll pick up tomorrow. That way we won't have to worry about having you write it down tomorrow. But we're going to talk about shifts now. Okay, shifts, S-H-I-F-T is what I was saying there. And these are shifts in the graph. These are like if I would pick up the graph and move it to another location. Okay, so I'll let you go ahead and get that down, and then I'll go ahead and give you your assignment, the entire assignment from this section. And we'll call it good for today. So,
Mr. Nichols, please call the office.
so for those of you watching the video, your assignment is going to be found on pages 264, 265, 1 through 19, 31 through 34.